Today we will be going with hydrocarbon with one more hydrocarbon after alkene. Now we'll study about alkyne. Now the general formula of alkyne is CnH2n minus 2. If we keep here n equals to 1, then we get H equals to 0, which does not make any sense. Now let us go with n equals to 2, then we have C2H2. Now C2H2 can be written as in this way. Hydrogen is being satisfied here, but carbon, they have 4 valences, they share with the other one and make a triple bond. This triple bond is also called acetylenic bond. ACETYLENIC, acetylenic bond. Due to this presence of acetylenic bond, they are unsaturated. And since they are unsaturated, the triple bond can be broken up very easily, and addition reaction goes with this. The general formula, already we have known this. The very first molecular formula is C2H2, which is ethyne. That is the condensed formula. We have write down the ethyne in this way. Structural formula can be written as in this way. Then the dot structure with the hydrogen we are going to write in this way, and the travel name is acetylene, and the IUPAC name is ethyne. Now we go with the isomerism of alkyne. Alkyne with 4 or more 4 carbon atoms can form isomerism. So with 4 carbon atoms in case of butane, we can see that it forms only position isomerism. Position isomerism means the bond gets changes. Here the bond is with one first carbon, so we are writing but 1I. Okay. And also here, and also in the second here, the position of this has been changed into this. This bond is with second number of carbon atom, so we are writing but2I. But in case of pentane, we have more than 4 carbon atoms, so here we have position isomerism as well as chain isomerism. So let us go with the position isomerism. Here there is a triple bond with the very first carbon atom, so we are writing pent1I, and here it is with the second carbon atom, so we are writing pent2I. Remember, for the chain isomerism there must be a methyl group, so here we can write down here the methyl group is present over here, so 1 2 3 4, so we are writing but, and the triple bond is with 1, that is but1I, and 1 2 3 with the third carbon atom there is methyl, so we are writing here 3-methyl but1I. Now we go with the laboratory preparation of ethyne, that is C2H2. In the laboratory preparation, we take calcium carbide and dropwise we use water to form calcium hydroxide and acetylene. Now the gas is, the order of the gas is sweet smell. Then since the gas is collected by the downward displacement of water. Why it is downward displacement of water? Because it is insoluble in water. Next, one more question can be, you can get it. What special observation should be taken? The special observation you should take that the flask should not contain air, because it is very explosive with the mixture of the air. To get rid of such conditions, we should use inert gas, or we should displace it with oil. Write 3 impurities formed during laboratory preparation of ethyne. So during the laboratory preparation of ethyne, we get lot of impurities, out of which hydrogen sulfide is there, ammonia is there, and arsine is there. Of course, phosphine is also there. But these 3 can be get rid of by using water, passing through the water, which gets absorbed in it. Next, how phosphine is get freed? The phosphine is absorbed by passing through acidified copper sulfate or acidified potassium dichromate solution. One more preparation from 1,2-dibromoethane. In dibromoethane, the structure is this, with alcoholic potash, with on boiling with 200 degrees Celsius, we get ethene. Next, since there is a triple bond in ethene, so it is a highly reactive, and due to highly reactive, it can form addition reaction. Now let us go with the first, that is the combustion, and since ethane has greater content of carbon, so it burns with a sooty flame. Now in combustion, we have the heat is being produced at the end product. Now let us go with the addition reaction. The very first reaction, that is addition of hydrogen, that is catalytic hydrogenation, is formed. That means here we are in presence of nickel, we are acting it, that hydrogen is being added up. Here there is a 3 bonds, triple bond, the bond has been changed here to double bond, and finally from the double bond the bond has been changed into single bond. So this is what we say is addition of hydrogen takes place from ethane to ethene and from ethene to ethane. The single transformation is given in this. Go through the examination hall, because sometimes they may not ask you this one. Instead of this they may put A here, instead of this they may put B, or whatever it may be. Then you have to write the fill in the blanks with these terms. Addition of halogen, that is chlorine. So ethene, when it reacts with chlorine, that chlorine we get it from the inert solvent, that is carbon tetrachloride. So we get first changes into CHCl with this one, and then further on the reaction we use, this is carbon tetrachloride, which is inert solvent, we get 1,1,2,2 tetrachloroethane. Also ethane, it gets reacted with the chlorine gas in presence of sunlight, in presence of diffuse sunlight. So what happens, the reaction becomes very vigorous. Iodine reacts with ethene in presence of alcohol to form 1,2-diiodoethene. Also reaction with HCl, the addition reaction takes place. Then for what's the here, the double bond is being changed into, the triple bond is being changed to double bond, then H is being added over here and Cl is being added over here. In this way again it has been changed into single bond. So finally it forms 1,1-dichloroethane. And the main use of ethane is artificial ripening of fruits, and number 2 is oxyacetylene welding. These 2 uses you must know before your exam.